Welcome. In this video series, we're going to look at the derivatives of inverse trig functions and log functions. We've actually seen log functions, but there's a few other techniques that we haven't fully explored yet. But let's get started. So we're going to do a little bit of review just with trigonometric functions. And of course, you can see the learning objectives here too. I forgot to mention those. But just as a warm-up here, so just thinking about functions being invertible, right? Another language bit just to mean that it has an inverse function if it has three things. So if it is a one-to-one function, one-to-one function, okay? This is sometimes called onto. And this just means that the domain is completely covered. It has to pass. Another way we can test for this one-to-one function is by making sure that it passes the horizontal line test. And again, since it is a function, it already passes the vertical line test, so it has to pass both the vertical and the horizontal. And then the other piece is that we know that the inverse exists, okay? And so what that means is that if we look at f of f inverse of x, that is equal to x, and that's also equal to f inverse of f of x. Okay, so those three conditions have to all be met if we know a function is invertible. Okay, now thinking about back to trig functions, right? We know that trig functions had inverses, right? But there were certain conditions attached to them. So, for example, when we were thinking about sine of x, we knew that the inverse function was sine inverse. And really, in this course, as much as possible, whenever referring to the inverse of a trig function, we're going to say arc, just to prevent confusion with the exponent idea. Okay, so. And what was that condition that allowed sine to be invertible? It was that we had to restrict the domain to be strictly from negative pi over 2 to pi over 2 inclusive. Okay, so we had to restrict the domain in order to get this arcsine function. Okay, and then just as a quick reminder, if we wanted to graph sine of x, right, on this particular domain, pi over 2 to say negative pi over 2, the values here, let's see, sine at negative pi over 2 is negative 1, and then 0, and then 1. I'm just kind of eyeballing this. Something like that, we'll call that 1, and we'll call this minus 1. And so it would do something like this on this domain, and then when we look at that inverse, right, it is a reflection over the line y equals x. So something, I need maybe a better scale set up here, but if that's the line y equals x, then we're reflecting, I don't think that's quite to scale, because what we would see is something like this for the inverse, okay? They would meet right here. So that would be something like arcsine, all right? Cosine, right? Cosine, it had an inverse function too, arc cosine, and its restriction to get to that invertible property is to be on the domain from 0 to pi. Okay, so slightly different domain. We had, let's see, call this pi, and this would be pi over 2. Pi over 2, we know cosine of pi over 2 is 0, and then we begin at 1. Oops, let's do that again. We begin at something like 1, 0, and then at pi, it would be down at minus 1. So we do something that's a little bit more gradual like that. And so our inverse function, again, reflecting over the line y equals x. And I'm, again, doing a very, very rough sketch. We would get something that looks kind of like that for arc cosine. Okay, and then the last function is oddly one that we use quite a bit in the course, is tangent and arctangent. Okay, so here the domain restriction that we need to employ is just we need one period of tangent, and that period ends up being from negative pi over 2 to pi over 2. Again, there's asymptotes at those places, so that's why we bound it there. So here, tangent looks much like what you would expect, so something like this. And then arctangent would be its mirror image, so something that might look something like this or so. Okay, for better pictures, this is where you go to Desmos and plot them on the appropriate window. That's my canned like disclaimer line for a better picture, right? So certainly you could go on Desmos. We're not going to take time on that, but just a quick little review on inverse trig functions and how they work, some properties related to them. And then next, as you can see, we're going to develop the derivatives of these inverse trig functions.